In this video, we will talk about a Cartesian product. So I want to motivate what that is through an example. And this is example 4 because I'm continuing my numbering of examples from the previous videos of this section. So we've already done 3 examples in this section, and this is our 4th one. So at a restaurant, you will choose one of 2 meals, a pita sandwich or a grain bowl, with a choice of 4 sauces: tahini, tzatziki, amba, or spicy. Okay, so we can express a food selection by picking a meal first. So for the meal, we can either choose a pita sandwich, let me denote that with a P, or a grain bowl, let me call that B. So P or B for the choice of meal. And then we choose one of these 4 sauces. So let me denote tahini with a T. Tzatziki, I need a different letter because I'm already calling tahini T. So maybe let me call this Z for the second letter in it. And then amba, let me call that A. And spicy, let's call that S. So we also choose a sauce. And for the sauce, we pick T, Z, A, or S. So I need to choose both a meal and a sauce. So we are going to construct an ordered pair. So for example, we could pick B for the meal, and then maybe we pick A for the sauce. So that ordered pair, this is a bowl, a grain bowl, with amba sauce. Okay, so that's a notation that we can use. It's kind of like writing a point x comma y, and those are called ordered pairs as well when we draw points on the xy plane. It's using that notation to indicate each of the stages of this process. Okay, and that'll take me to a definition. So we say that the Cartesian product of sets A and B, denoted A and then cross B. So the cross is like a multiplication symbol, and that's why we're going to call this a product. But the way I'm going to read this is I'll say A cross B. This is the set of all ordered pairs, A comma B, lowercase a and lowercase b, where lowercase a is an element of the set capital A, and lowercase b is an element of the set capital B. I could describe this as a rule, A cross B, and this is the set that consists of all ordered pairs A comma B, colon, which means such that little a is an element of big A, and little b needs to be an element of big B or capital B. Okay, so let's get comfortable with this notation in the context of this example. So in example 4, let's pick a notation for the 2 sets. So let's let M be the set of meals. And then, because I already have an S to denote one of my sauces, let me just pick a different letter to denote the set of sauces. Let me just call it D. So I'm going to say D is the set of sauces. Set of sauces. Then, let me zoom it out a little bit so I can still see the meals and the sauces. Then, M cross D. So that Cartesian product, what's everything that's in it? Well, for the meal, so I'm going to write the meal first. I could pick a pita sandwich, so I can write P, and then I pick one of the sauces to go after it. And I could do the same thing if I pick a bowl first. I could pick a bowl, and then I pick one of the sauces to go after it. But for the sauce, I have a bunch of different choices. I have 4 choices. So if I pick a pita sandwich first, I could pick any of the 4 sauces, which means I'm going to need 4 of these ordered pairs that start with a P. And then I'm going to fill in the sauces afterwards. Same thing, if I pick a bowl, I could pick any one of the 4 sauces afterwards. So let me leave myself some space. B, comma, and I would close my set. I'm going to go a little bit lower. And now let's write the sauces. So we could pick T, tahini sauce, for the sauce. Or we could pick Z, which was tzatziki sauce. Or we could pick Amba, which was A. Or S, which was spicy. So that is all the elements that are in this Cartesian product, M cross D. They represent each of these food selections, one of the meals and one of the sauces to go with it. So let's end this video by looking at one other example. So in this example, I'm going to let U be the set that has -2, -1, 0, 1, and 2, and S be the set that consists of the elements -1, 0, and 1. Let A be the set of ordered pairs x comma y, colon means such that x is in the set S, and y is equal to x squared. Okay, and B is the set of ordered pairs x comma y, such that x is in U, and y is equal to x squared. So we have a true or false question, and justify your answers. Part A asks, or it states, A is a subset of B. So to answer this, well, let's write out what A is and write out what B is so we can see if A is a subset of B. So A is a set, and the elements in it are ordered pairs. So the first element in it we're calling x, and x is an element of S. So the choices for x are either -1, 0, or 1. Those are the things that are in S. So we could pick a -1 for x. And if we do that, what is the y value? The rule says that y needs to be whatever x is squared. So it's going to be that -1 being squared. Okay, then I move on to the next choice for x. The next possibility for x is it could be 0. And if it was 0, then y is that thing squared. It's 0 squared. Okay, one more possibility. X could also be 1. That's the last element of S. And then y is going to be 1 squared, because that's the rule. Okay, those are the elements of A. And I can simplify this and get A is equal to -1 comma +1, because that's what -1 squared is. And then 0 comma 0, 1 comma 1. And there we have it. Those are the elements of the set A. Now I got to do the same thing for the set B. And B is really similar. It's just that X is now an element of U, which is a slightly bigger set than S was. So it's going to be really similar. But I'm going to do this one more quickly. For B, X could be -2, or it could be -1, or it could be 0, or it could be 1, or it could be 2. And then to get Y, we square whatever X is. So if X was -2 and I square that, I'm going to get 4. If X was -1 and I square that, I'll get +1. So quickly going through the rest, 0 squared is 0, 1 squared is 1, 2 squared is 4. So I have the set A and the set B. So clearly, A is a subset of B since every element of A is an element of B, which means this is true. A is a subset of B. All right, let's do one more part to this example. This asks, is B a subset of S cross S, this Cartesian product? For this, I want to give you an opportunity to try it first. We're up in the difficulty a little bit with this example, now that we have these Cartesian products in there. So it's a really good practice to try this. Pause it for 2 minutes to try this. 4, 3, 2, 1. Pause the video. Pause it for 2 minutes to really try this question. All right, so hopefully you've done that. Hopefully you paused it for 2 minutes to really try this. Let's talk about it together. So we know what B is from part A. So we need to know what S cross S is. So generally, this is going to be a set of ordered pairs. Let me just write A comma B, such that A, the first coordinate, needs to be in the first set, which is S. And the second coordinate is B, and that needs to be an element of the second set, which is also S here. So if I were to write these elements out, S cross S, and just so I can still see it, what is S? So negative 1, comma 0, comma 1, it has those three elements. I just want to write it out so I can go down and zoom in a little bit so it's easier for me to write. Okay, so let's write out all the elements of this, this Cartesian product. So A is an element of S. So A could be negative 1. And B, will be some other element of S. And there's three choices for what B could be. So I'm going to put three different spots. Negative 1 comma something, negative 1 comma something, negative 1 comma something. And then A could also be 0. And then if it's 0, I would have to do three choices then for what the second coordinate would be. And A could also be 1. So I'm just going to set it up here. 1 for the first coordinate. Okay, and once I choose what A is, now there's three choices for B. So either B could be negative 1. So let me just put negative 1s down this column. B could also be 0. So I'll put zeros down this column. And then it could also be 1, positive 1. So let me put 1s down there. And overall, notice that there's 9 ordered pairs. And I think that makes sense because there were three choices for the first coordinate, A. And there are three choices for the second coordinate, B. And 3 times 3 gives us 9, which is how many elements that we have total. Okay, so if I look at the set B, and I look at the set S cross S, is B a subset of S cross S? Well, no, this is false. This is false. B is not a subset of S cross S since there are elements of B that are not in S cross S like the coordinate, the ordered pair negative 2 comma 4. That's one example. And that shows that B is not a subset of S cross S. All right, so in terms of our goals for this section, we have finished our second goal, which is talking about how to construct mu sets from given sets using operations like unions, intersections, complements, and in this video we talked about Cartesian products.